So good morning friends. In the last lecture we have seen how the equilibrium constant value affected by the temperature, pressure as well as the concentration, right? How it affects, that we have studied. Today we are going to study the Hoff equation. Hoff equation. So let's start. Now we have seen that is delta G0 is equal to minus RT ln K. This equation can be rearranged, or this equation can be written delta G0 is equal to minus RT ln Kp when we are using the partial pressure. This equation can be written like this: delta G0 is equal to minus RT ln Kp, right? Then we have already learned at the starting of this chapter, that is delta G0 is equal to delta S0 minus T delta S0. What is this delta S0? That is the standard enthalpy of the formation, and delta G0 standard Gibbs free energy. Now we know the terminal. Suppose this is equation number 1 and this is equation number 2. If I put the equation 2 in equation 1, what it comes out to be? Before that we will rearrange the equation 1. Rearrange equation 1, what it comes out to be? Equation 1, rearrange ln Kp is equal to, this minus sign will come this side, therefore minus delta G0 divided by RT. Now put this equation number, let's consider this equation number 3. Put equation number 2 in the equation number 3. Put equation 2 in equation 3. Equation 3. What it comes out to? ln Kp is equal to minus delta G0, that is delta G0 is equal to delta S0 minus T delta S. Therefore this minus, instead of delta G0 we are writing delta S0 minus T delta S0 divided by this RT, right? Now multiply by negative sign, ln Kp is equal to minus delta S0 plus minus comes out to be plus T delta S0 divided by RT. Now this RT term, denominator RT term is divided by both the terms. Therefore again rearrange this equation. ln Kp is equal to minus delta S0 divided by RT. This minus and plus minus and plus, that is already we have multiplied. Again plus T delta S0 divided by RT. Now we have separated this denominator, therefore this TT will get cancelled and the equation comes out to be, how it comes out? The equation comes out to be, that is ln Kp is equal to minus delta S0 divided by RT plus delta S0 divided by R, right? Suppose this is equation number 4. Equation number 4. Now if the reaction is carried out at the two different temperature, this equation can be written. For temperature T1 this will be equal to Kp1, for temperature T1 this T will be equal to T1. Therefore for two different temperature, this can be written, this equation 4 can be written, ln Kp1 is equal to minus delta S0 divided by RT1 plus delta S0 divided by R. This is, suppose this is equation number 5. Now for the temperature T2 ln Kp2 is equal to minus delta H0 divided by RT2 plus delta S0 divided by R. Suppose this is equation number 6. Now, subtract equation 5 from the 6. Subtract equation 5 from 6. This can be written. That is ln Kp2. This is equation number 6. ln Kp2 minus ln Kp1 is equal to, if I rearrange directly, because this is plus delta H0 divided by R minus delta H0 divided by R, this term will get cancelled while substituting this equation from this equation, that is equation number 5 from equation number 6, that will get cancelled. What will remain? Minus delta H0 divided by R into 1 upon T2 minus 1 upon T1. Suppose this is equation number 7. How this equation comes? If I multiply this term and this term will get cancelled, we know that one. This will be minus term and this is the positive term. Now, if I multiply this is by this equation, minus delta H0 divided by T2 into multiplied by R, this minus delta H0 minus delta H0 divided by R T2, right? Minus will become again plus, that is plus delta H0 divided by R T1, because we are substituting this equation. Therefore, this is minus multiplied by minus, that is again comes out to be plus. This minus multiplied by this minus will be again, that is equal to plus. Therefore, we will get this form of this equation. Now, if you rearrange this equation, that is ln Kp2 minus ln Kp1 is equal to, if we want to remove this negative sign, we have to multiply this side by negative sign. Otherwise, we can rearrange this T2 and T1, that is delta H0 plus delta H0 divided by R, and this comes out to be 1 upon T1 minus 1 upon T2. We have just rearranged this equation. Therefore, delta H0 will be positive. Suppose this is equation number 8. Now, for the endothermic reaction, what is happening at the endothermic reaction? For the endothermic reaction, delta H0 is positive, right? Delta H0 is positive. Now, the T2 temperature is higher. Than T1 temperature, right? Therefore, this ln Kp2 divided by ln Kp1, overall this value. Let's wait. This value, overall this value, that is this value, this equation again can be written ln Kp2 divided by ln Kp1 is equal to delta H0 divided by R into 1 upon T1 minus 1 upon T2, right? Minus 1 upon T2. This overall value comes out to be negative. Why negative? For the endothermic reaction, if we increase the temperature, right? For the endothermic reaction, if you increase the temperature means this T2 value will be higher one. This T2 value is the higher one and this is the negative value. Therefore, this term, that is ln Kp2 divided by ln Kp1, comes out to be negative, since T2 is negative and delta H0 is positive. Negative multiplied by positive, that will comes out to be negative. Means simply for what? Simply for endothermic reaction, if we increase the temperature more product will be formed. More product will be formed. More product will be formed. And for exothermic reaction, what will happen for the exothermic reaction? We know that. What is the exothermic reaction? The reaction in which heat is evolved from that reaction. Therefore, if you increase the temperature, more reactants will be formed for the reversible reaction. For the reversible reaction, if the reaction is exothermic, if we increase the temperature, what will happen? This value comes out to be positive for exothermic reaction. This value comes out to be positive if you increase the temperature. Therefore, more reactant will be formed. For endothermic reaction, if you increase the temperature, more products will be formed. This equation, that is ln Kp2 minus ln Kp1 is equal to delta H0 divided by R, 1 divided by T1 minus 1 divided by T2 is called as the One-Top equation. One-Top equation. That is called as the One-Top equation. Remember that. One-Top VANT. Remember that this is VANT. VON. It's not VONT. Please make the correction. VANT. One-Off equation. Remember that. Now, we will solve the problem based on this equation. Right? Let's solve the problem. Problem number 1. So, problem number 1. Right? I hope you can see this problem. I hope you can read the problem. Right. Now, so what is the given in this problem? The equilibrium constant for the synthesis of ammonia, N2 gas plus 3H2 gas, equilibrium reaction, 2NH3, that gives 2NH3. Again, it will decompose to form the N2 as well as H2 gas. Right. The equilibrium constant is given for this reaction is 6.8 into 10 raised to 5 at 298 degree Kelvin. Now, predict its value at 400 degree Kelvin. Delta H0 for the ammonia, for the formation of ammonia, that is standard enthalpy of formation of ammonia is minus 46.11 kilojoule per mole. Now, remember that all the values are given in the kilojoule per mole and degree Kelvin, that is standard value they are given. Now, how we will solve? We have learned the one-top equation. That first what we have to do? What we have to calculate the delta H0 for the overall reaction, above reaction. The reaction is what? The reaction is N2 gas plus 3H2 gas, the equilibrium reaction, and that is 2NH3 gas. 2NH3 gas. Right? Therefore, we have to calculate first the overall reaction. Delta H0 is equal to what? It is what? It is the difference of standard enthalpy of formation minus standard enthalpy of formation of the product minus reactant. Here in this case, standard enthalpy of in this case, ammonia is the product and N2 plus 3H2 are the reactant. We have learned how to calculate delta H0 in the very beginning of this chapter, right? So delta H0 for what? For ammonia minus N2 plus H2. Therefore, delta H0 for the ammonia is what? How many number of ammonia? 2 into what? They have given the value. They have given the value what? For the ammonia NH3, that is delta HF0 for the formation of NH3, that is NH3 is equal to how much? Minus 46.11 kilojoule per mole. Right, kilojoule per mole. Therefore, ammonia minus reactant, that is 2 into delta HF0 ammonia, that is NH3, minus delta HF0 for what? Delta HF0 for N2 minus how many number of moles are there? 3 number of moles of hydrogen are there. 3 into delta HF0 for hydrogen H2. Right? This is the equation. Right? Now, delta H0 is equal to 2 into delta HF0 for NH3 that they have given, that is minus 46.11 kilojoule minus delta HF0 for nitrogen. They are not given, but we know that. What we know that the delta HF0, that is standard enthalpy of formation of the molecule in their standard state. This nitrogen is in the standard state and this hydrogen is also in the standard state. That is equal to 0. Multiplied by 0 minus 3 into this for the hydrogen also. Hydrogen is also in the standard state. Therefore, that is also 0. Therefore, this total value comes out to be 0. Therefore, delta H0 is equal to 2 into minus 46.11. If we multiply, that is simple mathematics, that comes out to be minus 92.22 kilojoule per mole. 92.22 kilojoule per mole. Now, this standard delta H0 for the overall reaction that we have calculated. Right? Now, we have learned the one top equation. What it was? It was that ln Kp2 minus ln Kp1 is equal to delta H0 divided by R into 1 upon T1 minus 1 upon T2. Remember that we have removed the negative sign here. Right? Now, this equation can be rearranged and this equation can be written like this. How we can write? ln Kp1 divided by Kp2 or ln Kp2 is equal to delta H0 divided by R into 1 upon T2 minus 1 upon T1. This equation rearrange. One top equation rearrange. Suppose this is equation number 1. What we have done? We have multiplied by negative sign. Therefore, negative sign multiplication, this comes out to be positive and this comes out to be negative. Right? And this term comes out to be this side and this term comes out to be this side. This term will be positive and this term will be negative. That we have written 1 upon T2 divided by T1. Again, this equation can be rearranged. How we can rearrange? That is ln Kp1 divided by ln Kp2, since it is the negative way. Therefore, suppose this is equation number 2. Just we have rearranged this equation. Right? Now, ln Kp1 divided by ln Kp2 is equal to delta H0 divided by R into 1 upon T2 minus 1 upon T1. Now we can put the value. Wow, what value they have given? This is for 298 degree Kelvin and this is for 400 degree Kelvin. Therefore, temperature T1 can be written from this data, that is equal to 298 degree Kelvin, and temperature T2 is equal to how much? 400 degree Kelvin. Right? And the value they have given at T1, that is Kp1 value, they have given Kp1 value is equal to 6.8 into 10 raised to 5 kPa value. What they have asked? What they have asked? Predict the value at 400 degree Kelvin. That we have to calculate the Kp2 value. Kp2 value is equal to how much? Right. Let's write the values given. ln Kp1, ln of Kp1. Kp1 value they have given 6.8. 6.8 into 10 raised to 5 divided by Kp2. That is also ln Kp2 is equal to delta H0 overall reaction that we have calculated. Enthalpy of formation of overall reaction we have calculated. Here it is minus 92.22 divided by R. Value of R in the kilojoule per mole, that is 8 kilojoule, 8.314. Since it is in the kilojoule, it multiplied by 10 raised to minus 3. Conversion factor 1 upon T2, 1 upon T2. T2 is how much? T2 is equal to 400. 400 minus 1 upon T1. T1 is 298 degree Kelvin. Right. If you calculate this simple elementary mathematics, 10 raised to minus 3, if you take upper side, that will be equal to 10 raised to plus 3. Right. That is equal to minus 92.22 into 10 raised to 3 divided by 8.314 into this multiplied by this, that is 298 minus 400 divided by 400 into 298. 400 into 298. If you calculate the value, if you multiply the value, right, simply elementary mathematics is there. Right, simply calculation, that is ln of 6.8 into 10 raised to 5 divided by Kp2, that is equal to, if you multiply the whole value, that is this minus 400 multiply 298 multiplied 298 minus 400, this minus value comes out to be, again let's calculate the values within a fraction of the second, or otherwise you can also calculate with the help of calculator. Remember that for the FYBSc, the university exam, non-programmable calculator is allowed. Therefore that is 298 minus 400, that is equal to minus 102. Right, minus 102, that can be written that is minus 92.22 into 10 raised to 3 divided by 8.314 into this value minus 102 divided by 400 multiplied by 298, that is, let's calculate, 400 multiplied by 298, that is equal to 119200. 119200. Now this minus and this minus will value become equal to positive value. Therefore 92.22 into 10 raised to 3 into 102 divided by 8.314 into 119200. If you calculate all the values, simply multiplication and division. If you calculate the total value comes out to be 9.49. 9.49, that is equal to ln 6.8 into 10 raised to 5 divided by Kp2. Right, Kp2. Now this is also ln Kp2. Therefore that can be written, that is ln 6.8 into 10 raised to 5 minus ln Kp 2 is equal to 9.49, right? If we rearrange this equation, if we take that side ln kp2, that is equal to, or if you multiply by negative sign for this equation, the ln kp2 will be equal to ln kp2 is equal to, I am taking this ln kp2 that side, therefore this will become negative. If I multiply by negative, this will become positive, and this value will become negative value. That comes out to be ln 6.8 into 10 raised to 5 minus 9.49, right? And if I take the ln value of this 6.8 into 10 raised to 5 minus 9.49, that is very easily that can be calculated. That value comes out to be, this is ln kp2, that value comes out to be 3.9398, right? ln kp2 is equal to, simply if I take the ln of 6.8 into 10 raised to 5 and minus 9.49, that comes out to be 3.9398. that we can easily calculate with the help of calculator. Therefore, if I remove the ln, we have to take the ln of the both side. Therefore, if I remove this ln of the both side, ln of 3.93 will comes out to be that is kp2 is equal to 51.41. we can easily calculate, right? We will solve the one more problem in the next lecture. I hope you are doing well. Enjoy the lockdown. Thank you. Bye bye.